Hey guys, welcome back to my channel. So today we are gonna discuss selection sort. Selection sort is basically a comparison-based algorithm, and here we have less number of swaps compared to bubble sort. You would see for each iteration, like it would make a swap with the least element, and it is not considered stable because the relative order of the elements are not maintained in case we have same elements, and the best, worst, and average time complexity for this is of n square, and as mentioned, comparison based. Coming to the space complexity, it is O1 for iterative solution and On for recursive solution because of the recursive stack, and we shall see both in the code. So let's go. So let's start with the iterative. It will take the array and n. So basically what we will try to do here is this is our array, and we will try to get the least element in the zeroth index. Okay, so for the very first iteration you will see that 3 will be in the zeroth index because that is the lowest. So let's start with the loop. And let's make one min index. So I will be assigned to min index, and we'll have our inner loop. Okay, inside our inner loop, we are going to make a comparison because j is pointing to I plus 1, which is the next element, or we can say this, considering our array, this is j and this is I. Okay, so we have to check if j or the incremented value more than I is less than the ith value or the zeroth index or not. And in this case, it is true. So there will be a swap because we have found our min index. So if j is less than min index, then min index will be assigned, newly assigned. And then let's go forward. There will be a swap. Okay, the value of ARRI is kept in temp, and in ARRI we will keep our minimum index and then we'll swap it. Okay, so basically what is going to happen is if I put a debugger here, we'll understand this better. Let me just print the array. Okay, so let's just run it once. And we see our sorted array. Now let's try to run it in debugger mode. Okay, so for the very first iteration, you will see that min index is 0, I is 0, n's value is 5, and this is our array present initially. So min index will be 1, okay, because this value is less than 12, right? So let's just move forward. And it will go through the entire array seeking for something with the lowest min index, but right now we have the min index as 1 because 3 was in this place, and that up until now is the lowest one. Okay, so if you see, We are done with this iteration and the min index is still 1, and in 1 we had 3, right? So this is the lowest one and it will be swapped with ARR of I, and in I you can see the index of I, or the value of I was 0. So I of 0 and min index, that is array of 1, will be swapped. So that is how it goes on. And now, if again we move forward in our algorithm, we will see that the second lowest, or the 12th one, okay, we are currently in this position and we have to find the second lowest, which obviously is 12. So you will see that min index again will be 1, because right now this is the placement of 12, which is the second lowest. So as we go forward, you will see min index is 1. Okay, and that is how we roll. Again, if you see in the array, this is the third lowest, right? And currently we are in this position, right? In 25th, I is equals to 2, and this is the third lowest. So the min index that will be calculated will be 0, 1, 2, 3, 4, and that is what we are getting for. See, the min index is 4. And that is how we proceed. Okay, now let's quickly go to the recursive solution. Let's just run this. And as mentioned, the space complexity is of n square, as there are two loops that we are dealing with, and sorry, the time complexity, yeah, the time complexity is of n square and the space complexity is of 1, as we are not using any extra space. And for the recursive one, we'll see a difference. Okay, so let's go the recursive. So we will be taking array n, and we need to provide a starting point, okay, because this is how we will do the recursive one. Let's just create the method. Okay, let's rename it start. Now, and start starts with 0. Okay, so there are two important things to recursive code. That is, one is the base condition and one is the call. So you definitely know that there is going to be a call like this, right? It is going to take array, it is going to take the length and start. But if I leave it like this, we will have an infinite loop, right? So a change needs to be passed on each and every recursive call. So that is why we are going to increment it by 1 every time. The simple meaning of this is, like, if we are starting with 0, the next time we'll start with 1, then 2, and so on and so forth. Okay. So since we are incrementing, or just incrementing that with start, it needs to have a stopping point, or the base condition, right? So this is our base condition. If this reaches the full value of the array, then it needs to return. Okay. Now let's take min index again, and min index will have the value of start. All right. Now we'll have our array. Array need not be start plus 1, but it should start with 1. And yes, again, our same comparison. We will check if array of I is less than min index. If that happens, then min index has to be assigned. Okay, now let's do the swapping. We'll have the value of min index, okay, and then in min index we won't have n, but we will have start, and in start we'll have temp. Okay, that is all we need to do. And let's just comment the selective iterative so that just the recursive one runs. And let's run it. And we see our answer. Okay. So again, for the recursive call, the same thing is going to happen. The least value. So this min index will have the least value, or the index which is having the least element every time, and we will be swapping it with the 0th position, and that is how we proceed. So thank you so much for watching this. Let's catch up in the next video.